In the vast tapestry of the cosmos, stars are the architects of the universe. Their lives, though long by human standards, are fleeting when measured against the infinite timeline of existence. Today, we follow the story of celestial objects large and small. Brown dwarfs, red dwarfs, a low-mass star like our Sun, and a mighty high-mass star destined for a dramatic end. Not all objects that form in a nebula become true stars. Brown dwarfs, often called failed stars, are celestial bodies whose masses are too small to ignite nuclear fusion in their cores. With a mass between that of a giant planet and a small star, brown dwarfs emit only faint heat and light from gravitational contraction. While they lack the fiery brilliance of stars, they remain fascinating objects that bridge the gap between planets and stars. Red dwarfs are the smallest and most common true stars in the universe. These faint, cool stars have a mass less than half that of the Sun and burn their fuel slowly, giving them extraordinary lifespans, trillions of years. Unlike larger stars, red dwarfs remain in the main sequence for nearly their entire lives, never becoming giants or supernovae. Instead, they quietly burn their hydrogen until it is completely exhausted. When their fuel is gone, they fade into obscurity as black dwarfs. But this stage is purely theoretical. No red dwarf has lived long enough to reach this point, as the universe itself is only 13.8 billion years old. A low-mass star like our Sun spends billions of years in the main sequence phase, burning hydrogen steadily. These stars live quiet, stable lives, providing light and energy to their planetary systems. As the hydrogen runs out, the star swells into a red giant. Its outer layers are shed into space, forming a beautiful planetary nebula, while the core becomes a white dwarf, a dense, dim remnant that will slowly cool over trillions of years. This is the peaceful end of a low-mass star's journey. A high-mass star, however, burns its fuel at an astonishing rate, shining tens of thousands of times brighter than the Sun. These stellar giants have short, turbulent lives lasting only a few million years. In its core, heavier elements like carbon, oxygen, and even iron are forged. But when fusion can no longer sustain the star, gravity takes over, triggering a catastrophic collapse. The result is a supernova, an explosion so powerful that it outshines entire galaxies for a brief moment. What remains depends on the star's mass. A moderately massive star leaves behind a neutron star, a dense object with the mass of the Sun packed into a sphere the size of a city. But for the most massive stars, the collapse creates a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. Though their lives may end, stars leave behind a legacy. The elements forged in their cores enrich the cosmos, becoming the building blocks for planets, life, and new stars. Thus, the cycle begins anew, a testament to the enduring beauty and power of the universe. From the smallest brown dwarfs to the most colossal black holes, stars and their cousins remind us that even in death there is creation. They are the lifeblood of the universe, illuminating its darkest corners and inspiring us to look up and wonder.